So let's talk about this diagram. This is a picture of a problem that I used to give my calculus students every year. We used to beat it to death. The problem that was described originally as we have the function y squared equals x cubed, which this is the graph of right here, or at least a portion of the graph. And the lines x equals 4, y equals 8, and this curve divides this rectangle into two regions. One region is OBC in light green, and the other is OAC, and we practiced revolving both regions about the x-axis, the y-axis, the line A equals C, using both disk washer method and then the shell method to prove that they both resulted in the same answer. So this particular video is going to focus on this problem right here. We're going to revolve the region OBC about the line AC. We'll first use the disk washer method, and then we'll use the shell method. This is the answer down here in the lower left-hand corner, 3,456 pi over 35. First, we're going to use the disk method, or the washer method. Let me write that right here, washer. And when we use the washer method, we're revolving around the line AC. When you use the washer method, that means the little thin rectangles are perpendicular to the axis of revolution. We're picturing revolving this little rectangle, about the, where's my pen here? I'll just click undo. Yeah, we're picturing revolving this rectangle about the line A equals C. And what we do is let the number of these disks or rectangles or washers have their number approach infinity, or the width of them gets smaller and smaller or approach 0. And it is, when you're using the washer method, you're using the formula pi times whatever the limits of integration are, outer radius squared minus inner radius squared. So that's what we have to figure out. What are the limits of integration, and what is the expression for the outer radius? What is the expression for the inner radius? And by understanding it with the washer method, the disks or rectangles are perpendicular to the axis of revolution, and it's this little distance right here that approaches 0. Well, that means actually we're going to integrate along the y-axis, so I should have had actually a dy here. And we will be integrating from 0 to 8. So the question now becomes, what is an expression for the outer radius? And the outer radius is really the distance from the axis of revolution to the farthest endpoint of the region that's being revolved. So we want an expression for this distance. And in some, I don't have the x squared here. In some problems you want to ensure that the distance that you're finding an expression for represents a positive number, and you can always get that by subtracting right minus left, or big take away small. So in this case, this point has an x-coordinate of 4. This point has an x-coordinate of 0. So it doesn't matter where you are on this region, or where your little rectangle is, the outer radius is always going to be 4. Matter of fact, if you revolve that region, you just get a nice big fat cylinder. So 4 goes here. Now in this set of parentheses, we need an expression for the inner radius, which is, let me go to a new color here. This is the inner radius right here, that distance. So we need an expression involving y, because we got a dy here, that represents that distance. If I could take this entire distance and subtract this distance, I would have this little distance right here. Okay, so the entire distance is 4. The question is, what is this distance? Well, remember this horizontal line, the y-coordinate here is some number between 0 and 8. And to find this distance, it's going to be a horizontal distance, or something x equals in terms of y. For every y along here, the distance from here over to here is something that we did to the y value. And this is it right here. The x distance is x equals y to the 2/3 power. In other words, I solve this expression, the original function, for x. The x distance, that's from here to here. You raise this y-coordinate to the 2/3 power to get this distance. So the entire distance, which is 4, take away y to the 2/3. That's the inner radius. Okay, so now I'm not going to take us all the way to this answer. I'll leave that to the student, but let's do a little bit of it anyway. I still have from 0 to 8. 4 squared is 16, minus. Now here I'm squaring a binomial, so I'll square the first term. Double the product of the two terms. And then finally square the second term. So that'll be y to the 4/3. Kind of messy there. But finally, when I remove the parentheses, 0 to 8, 16 minus 16 is 0. Opposite of 8y to the negative 8y to the 2/3 is 8y to the 2/3. Minus y to the, that was 4/3, so that'll be y to the 4/3. And this is still dy. Okay, now the antiderivative, I'll just do this real quickly. 8y, raise the exponent by 1, 5/3, multiply by the reciprocal of the new exponent, minus y to the 7/3 multiplied by the reciprocal of the new exponent. Of course, we're going to evaluate that from 0 to 8 and multiply the whole thing by pi when we're done. And of course, remember when we substitute 8 in for y, this is like the cube root of y. Cube root of 8 is 2. 2 to the 5th is 32. It gets pretty messy. Here we're going to have the cube root of 8 is 2. 2 to the 7th is 128. And you can see the denominators of 3 and 7, or 5 and 7, when you get a common denominator, it'll be 35. That's why we get this 35 here. So I'll leave the rest of this to the student. You should get this answer if you simplify this expression. Now we're going to do the same problem using the shell method. And we better get the same answer. Let me pause the video for a second. And at this point now we're going to use the shell method. I don't have all the other what is going on here? There we go. All the other details that I had on the first picture, but it's the same idea. We're using, in this case, the shell method means that the little rectangle that we visualize is parallel to the axis of revolution. And remember, we're using the formula 2 pi times, well, since the rectangles are now perpendicular to the x-axis, we'll be integrating along the x-axis, which means we'll be going from 0 to 4. And what does the shell method do? Well, the first part is the height of the shell. And in red, that's this distance right here, or this distance right here. That's the height of the shell. That's what's going to go in here. Then we take that times what we call the average radius, which would be the distance from the axis to the center of the shell. So an expression for that distance is what goes in here. And finally, the width of the shell is represented by the width of the rectangles, whose widths are getting smaller and smaller, so that'll be dx. So there's the hard part, is figuring out what goes in here for the height, what goes in here for the average radius. So the height, remember we had x squared, no, y squared equals x cubed was the original problem. We'd like to solve for y in terms of x, so that's y equals x to the 3/2, because we're going to be finding y distances. So the height of the shell is again this distance right here in terms of x, some x coordinate. So what we want to do is say, well, really this distance right here is this distance, the entire distance, take away this distance. Okay, so the entire distance from x up to here is 8. Now the question is, what is the distance that we want to subtract to take away from that entire distance to leave us the height of the shell? And in terms of x, this y distance, for every x coordinate here, if I raise that x coordinate to the 3/2 power, I will get this distance right here. So if I take away x to the 3/2, not the greatest 2, x to the 3/2 from 8, I will have the height of the shell. Okay. Now let's figure out what the average radius is. That is going to be well, here's the whole distance from here to here is 4. I want to take away this part, and that will leave me the average radius, the distance from the axis of revolution to the center of our typical shell. So the whole distance is 4. Take away, what is this distance? Well, it's just x. And there we have, we're done setting up the integral. And I'll take us a little bit further. Here we're kind of using FOIL, multiplying two binomials together, so I'll get 32. I'll get minus 8x. I'll get minus 4x to the 3/2. And I'll get plus x to the, add the exponents, 3/2 plus 2/2 is 5/2. dx. Okay, and it doesn't look like there's much simplification going on there, so I can find the antiderivative right away, evaluating from 0 to 4. And this will be 32x minus, raise the exponent by 1, divide by the new exponent, or multiply by its reciprocal. So minus 4x squared minus 4 times, raise the exponent by 1, multiply by the reciprocal of the new exponent, and running out of room here again, 5 to x to the 7/2 multiplied by 2/7. Okay. You can see if you put 0 in for x, you're going to get all zeros, so it really is going to be 4 substituted for x. Simplify it all, multiply by 2 pi, you should get that answer that I had on the first slide, 3,456 pi over 35. That's the answer. And you get the same answer whether you use the shell method or whether you use the washer method. So hopefully that helped you visualize how to find those distances. You have to figure out whether to solve for y in terms of x or x in terms of y, whether your rectangle is perpendicular or parallel to the axis of revolution, and go from there. So there you go. Enjoy.